Welcome to the Crazy Hat Chemist. So another video in bonding and molecular structure. So let's get moving. Bam! So today we're talking about carbon dioxide's molecular geometry and oh so more. So carbon dioxide, what's the formula for carbon dioxide? Everyone should know that. Carbon, di for 2, oxide, boom. CO2. We're going to look at our periodic table, get the number of valence electrons for carbon. There's 4 of those. And the valence electrons for oxygen, that's 6. How many oxygens? 2. We're going to add these numbers up and we're going to get 16. We're going to divide this by 2 because we want pairs of electrons instead of total electrons, and that gives us that magic number 8, like our 8 ball. So the least electronegative element goes in the middle. Now, which one would that be? Oh, of course, that would be carbon, of course, because oxygen is the second most electronegative element. So the carbon goes in the middle. Now, I'm going to place the oxygens around it like thus in the X marks a spot pattern. Now, I'm going to dump out the electrons in the order from the Lewis dot structure rules. That is, the first rule is to place bonding pairs of electrons between the central element and the outside elements. I have done that like such right there. Now, I want to place lone pairs on the outside elements, and I have done that there like that. Okay, I'm going to verify the octet rule for oxygen, and oxygen must have an octet, and that is totally fine. That's super cool right there. Now, carbon in the middle is deficient of an octet. I mean, it only has 4 electrons around it, and it needs 8. So it needs 4 more. So how am I going to get 4 more electrons when I've actually already used all 8 pairs of electrons? So I don't have any more electrons to place there, therefore I must move around the electrons of which I already have. So the possibilities, I'm going to move the electrons to the inner bonds to accomplish an octet rule for all the atoms. So I'm going to keep these here but move them in, okay? And that will give me this Lewis dot structure, which is a double bond. Okay, so hopefully you see that. Now, if you circle around the carbon, there are 4 bonding pairs, which are a total of 8 electrons. If you circle around each of the oxygens, then you have 2 bonding pairs and 2 sets of lone pairs. That's a total of 8. So that is the octet rule which must be applied. Okay, so now we're going to look at the X-like structure for this. The A in the middle, that's the carbon, and the X on the outside are the 2 oxygen. So that's just, then there are no lone pairs on the central element, so it's AX2. That is 2 bonding and 0 non-bonding regions. That is 2 bonding domains. That double bond counts as a single bonding domain because it's localized between the carbon and the oxygen, and the carbon and the other oxygen. Okay, now from this we should be able to get our shape, which is AX2, or 2 bonding and 0 no bonding. That is linear in shape. What's the bond angle for something that's linear? That is, of course, a 180. Now I'm going to get the hybridization. So that's SP. Oh, I'm done. That's SP hybridized. Now I'm going to get the molecular geometry of this. Okay. So the molecular geometry of this looks like this here. Hopefully you should see that. That's linear. That's 180. That's SP hybridized. These are the double bonds right over here that you cannot rotate. Now, is this polar or non-polar? So oxygen is more electronegative than carbon. Therefore, the bond polarity goes from the carbon to the oxygen. From the carbon to the oxygen, but it's the same pull on both sides. So it's like a tug-of-war game where nobody wins. So therefore, it is non-polar, okay? Because it's an asymmetric. You cannot draw a dipole, a molecular dipole for the entire molecule, okay? Hopefully you enjoyed that. I got a cool hat for you here. It is like a beret. It's the perfect pumpkin hat. Isn't that beautiful? Give me a thumbs up if you like that video. Please subscribe to my YouTube channel. Pass on my YouTube channel to all your favorite friends who love chemistry or are just confused by chemistry and need to know more.